Hello friends, welcome to Risingpearl.com. Today we are going to take a look at what is question number 27 that appeared in 2016 CBSE Class-X Math exam, and how do we go ahead and solve this question number 27. So question number 27 goes like this. The houses in a row are numbered consecutively from 1 to 49. Show that there exists a value of x such that sum of numbers of houses preceding the house numbered x is equal to sum of numbers of houses following x. Now friends, you remember there was a question earlier, I think between question number 1 and question number 10, if I remember that correctly, which was on arithmetic progression, and I told you that one seemed to be one of the most hardest question, if not the hardest question on this exam. So this is another question. Surprisingly, both these arithmetic progression questions are fairly challenging. But I still believe that the last one, the one that we had seen earlier, was indeed more harder, challenging to solve between that and this question. But no doubt this is another very interesting question, and it will be a lot of fun when we solve this. So let's make sure that we understand the question very clearly. So what we have is a whole lot of houses which are in a row, and they are numbered 1 through 49. So let's write them 1, 2, 3. No, I'm not going to write all of them. 5, 6, ... and there is a number x, and then 48 and 49. So these are all the homes. It may seem like numbers, but basically these are all the homes, and these are the addresses, let's say that, and the numerical part of the address goes like this. So 1, 2, 3, 4, 5, 6, and then we keep going. And what is x? We will come to that just in a moment. And then we get to 48, 49, right? Now x, the question goes like this. Show that, we have to show that there exists a value of x, meaning there exists one such number x somewhere in between 1 and 49. Do we know if x is equal to 4? It could be. Or x is equal to 6? It could be. Or x could be equal to 48. We just don't know what is x. X is some number in between 1 and 49 such that the sum of numbers of houses preceding the house numbered x. That means if this is x, right? So the sum, if we add all these numbers till the house, let's say till here, if this was the house before x, so sum of all these numbers is equal to, and if we say that from here this starts the numbers after x. So the question is saying, show that there exists such a number x between 1 and 49 such that the sum, this sum, if we call this S1, this sum, that is S1 is equals sum of all these numbers till x minus 1, the number immediately before x is x minus 1, is going to be equal to sum of all these numbers, that is from x plus 1 through 49. Let's call this, if this is S2. So we have to find out that indeed there is a number x such that S1 is equal to S2. And this is what we have to find out. So we have to find out that there is a value of x for which this one is equal to this one. So I hope, friends, at this point the question is clear. So how do we do this? So what we are going to do, we are going to first find out the number, so how many terms are there, right? Remember the formula to find out s of n number of sum of n number of items. The formula is the number of items by 2 times 2a plus n minus 1 times d, where d is the common difference. So what is n? N is the number of terms in our arithmetic progression. A is the first term, N is again the number of terms, and D is the common difference. Because these houses are numbered 1, 2, 3, 4, 5, 6, so throughout between 1 and 49, our common difference for this is equal to 1. D is equal to 1, right? Now, we have two sets of numbers, or two series. One goes from 1 through x minus 1, right? Because if this is x, what is the last term before x? This will be x minus 1, right? So this will be x minus 1. Similarly, this term which is right after x, what is that term? That term will be x plus 1, right? Because x minus, this is x, this will be the one right before will be minus 1, x minus 1. The one right after that will be plus 1 or x plus 1. So before we calculate the sum of n number of terms, we need to make sure how many terms are there and what is the first term and what is the common difference. Now for both of these, common difference will be 1, right? Now for the first series or sets of number, let's call it S1. So how many terms are there? There are x minus 1 number of terms, right? Because we start from 1 and go through x minus 1. So n for S1, n will be x minus 1, right? And what will be a? Well, we start from here, so a will be 1. And d, what we just talked about, will be 1 as well. So for S1, these are the values for n, a and d. So S1, which is sum of 1 through x minus 1, will be n, which is x minus 1, n by 2 times twice a, 2 times 1, plus n minus 1. N is x minus 1. This is n. N minus 1 times d is 1. Or in other words, if we just write this, it will be x minus 1 times, let's open this. So we have 2 here, which is this 2, plus we have x here, x, and we have minus 1 here, so this is minus 1. So this is minus 1, and then we have minus 1 again, so minus 2, and 1 times all of this will be the same, so it will be x minus 2. So let's make sure, so we got this 2 here, 2 times 1 is 2, which is this 2, plus x minus 2, so it will be x minus 1 minus 1. The entire thing divided by 2, or if we just simplify this, this will be x minus 1 times, so this is like minus 2 plus 2, so this will cancel out, so we will be left with x divided by 2. So the sum of these houses, or sum of these house numbers, will be x times x minus 1 divided by 2. Now let's take a look at the second set of numbers, right? So we talked about 1, 2, 3, 4, 5, 6, and dot dot dot. We get to x minus 1, x, x plus 1, then we go like this, then we have 48 and we have 49. This is what we have, right? And we just saw the sum of these numbers all the way till here, we were calling it S1. We found out that S1 is equal to x minus 1 times x by 2. Now we have to find out the sum of these numbers. So again we have to find out how many terms, this is S2. So we have to find out how many terms are here, right? So how many terms are here? So we go from x plus 1 through 49. Now what is important to understand, friends, is that how do we calculate for, now we are talking about S2, right? We are talking about S2. So how many terms are here? Now if you think for a moment, let us say that we want to find out how many terms are between 1 through 6. if we were to find out how many terms between 1 through 6, how are we going to do it? Well, we will say there are 6 terms, right? We can count 1, 2, 3, 4, 5, 6. But the other way to do that is, if you want to find out how many terms are there, we can take 6, right? Let's do probably here. We take 6 minus, we subtract the first term, right? So we take the last term, we subtract the first term. So what do we get? 6 minus 1 is 5. So are there 5 terms? No, there are 6 terms. And then we add plus 1. The point I'm trying to drive at is, if I know the last term and if I know the first term, so it will be the last term minus first term plus 1. So to find out the value of n, which is the number of terms here, for now we are focusing on S2, right? So n, the number of terms here, we'll take the last term, which is 49. We will subtract the first term, which is x plus 1. So we took the last term, we subtracted the first term, and then we are going to add 1. So this will give us how many terms are there in this set of numbers in this series. So I want to make sure that you really understand this. So for example, if you were to take 3, right? So how many terms are between 1 and 3? 1 through 3. You will say, well, there are 3 terms. But that can be also expressed as, take the last term 3, subtract the first term, and then add 1 to it. So then you will get 3, right? So similarly, we took the last term, subtracted this term, x plus 1, so took the last term, 49, subtracted x plus 1 from it and added 1. So if you just open this up, what we will get is, this will be, let's make sure we get this right, so this will be 49 minus x, 49 minus x minus 1 plus 1. So plus 1 minus 1 cancels out, it will be 49 minus x. So this will be the number of terms that we have over here. So now that we know that, and the first term is x plus 1, let's go ahead and find out S2. So S2 will be number of terms, which we just found out, 49 minus x. Number of terms divided by 2, right? N by 2 times 2 times a. What is a? A is the first term, which is x plus 1, right? So 2a plus n minus 1. What is n? N is 49 minus x. So n minus 1 times d. D is 1. So let's make sure that we get this correct. So what we have, this is 49 minus x by 2, right? 49 minus x by 2 times, so if you open this up, it will be 2x plus 2 plus 49 minus x minus 1. This should be, actually we can say this is 48 minus x, right? Or let's see if we can actually write this way, then we will have this as 49 minus x by 2 times, so 2x minus x will be x, right? And 49 for our 2 plus 48 will be 50 by 2. So what we have here is that we have 49 minus x, 50 plus x divided by 2. So this is S2. So the question is there a value of x? Is there a valid number between 1 and 49 for which S1 is equal to S2? So the only way to find that out is we will actually equate S1 to S2 and find out if x has any real root, or if x has any real value. Meaning we will equate S1 to S2, S1 equals S2, and solve for x, right? So let's do that next. So what is S1? We know that S1 equals, let's make sure, x times x minus 1 by 2, and S2 is it equals 49 minus x times x plus 50 by 2. So let's write it over here. So we have S1 is equal to S2. So S1 will be x minus 1 times x divided by 2. And S2 is 49 minus x times x plus 50 divided by 2. So 2 and 2 will cancel out, and now we are going to solve for x and see if x has any value between 1 and 49, right? So here what we are going to do, we are going to now simply open up the brackets here. So it will be x squared minus x, and over here what do we get? So 49 times x is 49x, right? 49x plus 49 times 50, right, minus x squared minus 50x. So if we just simplify this a little bit, we will get, we have minus x squared, right? So 49x minus 50x will be minus x. So in other words, on this side we will have 49 times, this is multiplied by 49 multiplied by 50 minus x squared, right, minus x squared minus x. 49x minus 50x is minus x. So what we are going to do now, so we are going to take all of these terms on the left hand side. So what we will get is, so we have x squared minus x, so this minus x squared will become plus x squared on the other side. So it will become x squared plus x squared, 2x squared. Now this minus x and minus x actually cancels out, right? And then on this side we have 49 times 50, right? Or from here we can say that x squared will be equal to 49 times 50 divided by 2, right? And then this cancels out, this will be 25, 2 25s are 50. Now 49 is 7 squared, 25 is 5 squared. So x squared is equal to this. So x is equal to square root of this, which will be 7 times 5, which will be equal to 35. Now remember, x squared is not square root obviously, so x squared is equal to this, so x equals square root of that, so 35. So indeed we have found the number 35 between 1 and 49, for which S1 is equal to S2. So yes, there exists such a house number for which S1 equals S2, and that number is 35. X equals 35. Now this is very straightforward for you to check, right? So all we need to do now, if you have time and if you want to just check if your answer is correct, so what we are saying is now 1, 2, 3 all the way, right, 34 and then 35. X is 35, right, and then we have 36, 37, then all the way till 49. So what we are saying is S1 is sum of all these terms. We can actually find out this. So there are how many terms? There are 34 terms. So this will be 34n by 2 times twice a plus n, there are the 34 terms, n minus 1, that will be 35. Actually we should say that this will be n minus 1, so 34 minus 1, 33, right? Or this will be 34 times 35 by 2, right? So this is S1. Now what about S2? We don't have to go ahead and solve all of this. We are just simply trying to make sure that these values are same. We are just checking our answer. And then we have to find out the sum of these sets of numbers. Now remember, this entire part, the second part, what we're doing now is just cross verification. Our question is done. We have already solved it. We have solved for x. X is equals 35. That is the answer, right? We know that x is equal to 35. We are just double checking our answer. If we have time, we just want to double check that this is indeed correct. So these numbers will be, sum of them will be this. And now how many numbers are over here? The terms. So there are, we talked about this earlier, if we have 39 minus 36 plus 1, this many number of terms. So if we do this, this will be 9, so this will be actually 50 minus 36, which is going to be equal to 14. So n is 14, so n, 14, n by 2 times, twice 2 times, first term is 36, 2 times 36 plus n minus 1, n is 14, minus 1 is 13, 13 times d is 1, so it will be just that. So we have 14 times, so this one, this will be 72, so we have 72 and 13, if we add them we will get 85. This times 85 by 2. So now if we think about these two numbers, so we have, let's see if there is any way we can actually break this down a little bit more. So, well, they both are 5, right? So let's do one thing. So we can actually write 85 as, I'm just trying to make sure without doing the entire calculation, trying to make sure if these, we can say these two numbers are equal or they are not equal. So what we can say is that, let's do one thing, let's write them in the factor. So here, so we have 14 times, so this one will be 5, actually 5 17s, this is 5 17s 85 by 2, 5 17s 85 by 2, and so let's probably leave this at this and see if we can break this down to the same form. So now 34 is 17 times 2, and this is 7 times 5 by 2, right? Yeah. So now 17, we have 17, we have 17, we have 5, we have 5, and 7 2s are 14, so this will make it 14, and we have 14, and divided by 2. So indeed we are seeing that S1 will be equal to S2. For x equals 35, these two sums will be indeed equal. So friends, this is the solution for question number 27.